entitled Live Demonstration of the Aphanomyces Crop Rotation App. My name is Allison Fletcher and I'm the Research Project Manager for SPG, and I'll be the host for today's session. Just a couple of housekeeping notes for those in attendance today. If you provided either a CCA or a CCSC number at the time of registration, you will receive credits for today's session. In addition to that, after the webinar concludes, a recording is going to be made available on the SPG website. So be sure to watch for an email from us on how to access that recording. At the end of the presentation portion of the webinar today, there's going to be a live question and answer discussion. So if you do have questions as we go along today, please type them into the questions box on the GoToWebinar control panel, and we can address them at the end. So SPG is guided by a grower-elected board of directors and is driven to create opportunities for profitable growth for Saskatchewan pulses. One of SPG's 5 key result areas relates to boosting profitability by reducing agronomic constraints that growers are facing. Today's session focuses on a topic that supports that goal. We do recognize the value that agronomists bring to growers in Saskatchewan as you're key in spreading technical knowledge and widening that reach of this information that we're providing to all your growers and your grower networks. So we do thank you for taking the time to be with us today. So we are pleased to be joined by Dr. Steve Shirtliffe. Steve is a professor in the Department of Plant Sciences at the University of Saskatchewan who teaches and conducts research in the areas of digital agriculture, weed control, and agronomy. So welcome, Dr. Shirtliffe.
Well, thank you very much, Allison, and it's indeed a pleasure to be here today on a day that I dare say for much of us, especially maybe in central and southeastern Saskatchewan and into Manitoba, that is much better to be inside than outside. Normally we'd be hoping to be happy to be outside today, but given the cold weather, yeah, and I'm hoping that my presentation today goes like the first part of the SpaceX launch today. Those of you that are on Twitter, and I know this was well promoted on Twitter, may have seen the beginning part of that, where that beautiful, SpaceX rocket lifted off, and then in a few minutes later, when it was reaching higher in orbit in spectacular fashion, blew up. I'm hoping to be more like the spectacular liftoff today. So anyways, today I'm going to talk about some work that we've been doing in somewhat related, well actually somewhat related to SpaceX, in the fact that SpaceX is one of the major launchers of satellites in this world, and we've put together an app using remotely sensed data. We're kind of bringing agronomic, we're bringing big data agronomic tools to farmers using remotely sensed information. And those of you that know me may be a little bit surprised what's Shirtliffe been up to, but in the past few years we've started working much more in the digital ag area, and I think I'm going to start sharing my screen now. And there it comes. I think everything looks good. Is that correct?
That looks great.
Okay. So what we're today is we've put together a Aphanomyces risk evaluation app. I think I always like having a catchy name, so we called it Area, because it's dealing with areas. It's using satellite imagery as I'm going to show you from a few different sources put together to help us learn something about the risk of growing an Aphanomyces susceptible host on an area, on a field for a given year, for the upcoming year. And I'll show you how that works. But first, we'll get into a bit. I want to thank my co-authors. Tuan Ha is a research associate in our lab that has been a huge help in this. We also had Ari Marina Flores, who was the original programmer who started working on this. He left. He actually left a while ago, and since then we've had Namtran working as a programmer on this project, and as well as myself and Tuan. We were kind of the first ones, but the more intricate stuff we got in there. I also want to express thanks, of course, to Saskatchewan Pulse Growers, SPG. They've supported this project and they put on this webinar, so that's wonderful. They were very receptive to this idea when I came to them about a little bit more than a year ago. And I also want to thank that while I'm part of the College of Ag Bio, we are in my lab. I've renamed the imaging part of my lab the Crop Imaging Lab. But we are also, a lot of this work was started by this. I'll have to move this a bit. This Canada First Research Excellence Fund, which funded the PERC a few years ago and got us going down this pathway, working with computer scientists and geneticists, plant breeders, and engineers, doing all this cool stuff, which allowed us to transition into this area. So let's get going. Maybe first you can see some satellite imagery here that will make reference to some, look like blobs. These are fields here. This is showing crop type, which we'll get into. This is showing temperature for different or precipitation for different polygons, and a measure of that. What does that have to do with the Aphanomyces? Well, that's what you're going to find out today. And let's advance here. So Aphanomyces root rot. I think everybody who's here probably knows this is a devastating disease, especially in peas. It's been a huge problem. It gets in the roots and infects the plant, and it essentially kills off the roots. You get that very thin brown root and lentil can also be a host as well. There has been, there's also, you can find it often in wetter areas of the field. You've seen this picture down here from Dr. Sabina Benitza. We've done some work on the agronomic side, working with Shama Chatterton and trying to find agronomic treatments, if there's intercropping or if there's some previous crops that can suppress the disease. And to be honest, we haven't found much, or Shama hasn't found much. There's not much to do for classic control. Fungicides, seed treatments can control seedling a bit, but it'll outgrow that and connect it. Foliar fungicides similarly have very little effect. And what we're really hoping for, work is being done, some good work is being done by Tom Warkentine, is to get some resistance into that. But we're still not there. Tom has one variety, or Dr. Warkentine, I should say, has one variety that has partial resistance to Aphanomyces, not Fusarium, but to Aphanomyces root rot. There's also Fusarium root rot that is just going to be tested at the co-op trials this year. So it's not going any further. So I guess my point is here is we're kind of this is a devastating disease, and we don't have any quick control methods, etc. It's a persistent disease. It needs long rotations. I pulled an image off of an older image from Tyler Burns off of Twitter here, and I think this post and this aerial image really sums it up. Here's the effect of crop rotation. Here is in a wet year where peas were grown 4 years previously. Actually, this 2019, that wasn't even that wet of a year, but you can see how devastating the Aphanomyces root rot was on this side, and this side had never had peas. So he was getting 80 bushels and basically 40 bushels. It cut his yield in half. So it's a very persistent disease. I won't get into how long we're assuming, 8 to 10 years in the model. And the length of rotation that you need may also depend upon that initial infection. If that initial infection was, or if the past time peas were grown was really wet and there was a lot of inoculum built up there, obviously it takes longer for that to break down over time. And that's because, and soil moisture is a big effect. Here's some slides from Sabina and Shama, and showing the effect of topography on this disease and the fact that it's kind of somewhat of a spatially isolated disease in some cases. You can see the lower areas of the field. In wet years, it's much worse. Although even in dry years, in fields that have a lot of inoculum, Aphanomyces can be bad. But initially, in those wet years when it's building up, the inoculum can be bad, and it's often found in these lower landscape positions of the field. And of course, Saskatchewan weather, we'll talk about that in a while, it varies a lot. And some years, and you cannot predict that. You don't know what it's going to be. So basically, you're kind of stuck with crop rotation. If we can think back to this one, we're trying to avoid planting our peas onto fields like this that have a lot of inoculum growing in there. So that requires that you have to think about several things. And here, I'm just going to have to switch screens here for a second. I'm going to escape out of this. Connected to webinar. Okay, I think we are back. Is everything looking okay from the other end?
Yes, that looks much better.
Okay, sorry about that. That was a bit crazy. So anyway, so I was at the point of describing that Aphanomyces is a big problem, and really to manage it well, we have to use avoidance. We have to avoid planting on that. And SPG, Saskatchewan Pulse Growers, first put out a fact sheet that I thought was brilliant back in 2019, this reducing root rot risk fact sheet, which is linked to in the meeting notes. If you look under handouts, it's handout number 1. And it goes through some of how you can reduce your risk of getting root rot. And the first one is testing the field. And that obviously makes sense, that testing the field if you suspect it. I'm not going to deal with that at all because I'm not going to be talking about testing. But I'm going to talk about is reviewing the past field history. How many times were lentils grown in there? What was the environment when lentils were grown? And how long has it been since we've grown those lentils? We know that the moisture, that it changes a fair bit in the lentils, so etc. That has a big effect, and the crop rotation has a big effect. So all those factors, as well as soil, as well as the soil type, which influences the drainage, is something we're going to go into. And they put together this really nice reducing root rot risk, and try to say that 3 times fast. I'm surprised I said it this time correctly in the practice session. I muffed it up completely. But you can see here we have considerations for high risk. What was the environment at the last time that peas or lentils were grown? Above average or below average? Where were the symptoms? Was it patchy or not? What are the field conditions? Is it got a light textured soil or a heavy textured soil? How often how many times has it been grown in the past 20 years? And how long since the last time the lentil's been grown? These are all things. Right at the same time I was doing this, I was getting involved in some research using something called the Google Earth Engine. And one of the things that I discovered, that there was something called the annual crop inventory. And this is something that Agriculture and Agri-Food Canada has been doing since 2009. Heather McNairn was the lead scientist behind this, and she figured out a way of classifying the crop type that is grown in a field from satellite imagery in space, using optical and radar satellites to be able to determine pretty accurately. Initially, they were about 85% accurate. Now they're closer to 95% accuracy in Saskatchewan for most crops. And so they can classify every year using satellite imagery what crop is being grown in every field in Western Canada. Interestingly enough, so they have this, so this data is available out there. It's available on the Open Canada site, and you can go and download it all, but it's hard to work with. But then along came something called the Google Earth Engine. And so there's this the Google Earth Engine is a cloud repository, and maybe I'll click to the basis of it. This is the kind of the home base of the Google Earth Engine. It allows you, through using some code, to access different data sets that are available. Here's one of the data sets, the Canada Annual Crop Inventory. In this case, we're just displaying it for the year 2017. And you can see, so if I click off this layer here, you can get an idea of where we are. We're in, there's Rosetown, those of you that not sure where Rosetown, here's Saskatoon, Rosetown is there. And here's a layer that they have classified that Leander Campbell is the main technical person that's working with this program now, that's working with us every year. And so every year, using satellite imagery, they put together a map of what crops were grown where. And you can see here it's displayed in different colors. If we look at some of them, well, and I know I've memorized some of the colors. These bright yellow ones, this is 153. If we go back to this list here, we can see that 153 is in fact canola or rapeseed. So, and that's the darker the darker, this gray color here is 146. I think that's spring wheat. And these kind of bronzy brown ones, 174, are lentils. So this is available every year. And through this interface, you can actually go in and you can actually look at how, at what it is in different years. You know, you can kind of display that data. There's 2018. I can change it to 2019. This is all happening in real time. So you can actually, so this is there. So you can actually put together with a bit of programming a way of looking at the crop rotation over time. And I was teaching a class at the time, and that's what I did, is I put together a way of looking at this so we could look at the frequency of, in this case, this is of pulses grown in rotation in Saskatchewan. And if we pull the slider back here, we can kind of see where we are. And areas that are more red or yellow have higher frequency of pulses in rotation. And this is what kind of prompted me to get this idea to put together the Aphanomyces risk app. Maybe I'll start the demonstration of it now, and then we'll go back and talk a bit more about how I got some of the other data of it. When you first open it up, this is what you see. This is the Aphanomyces risk evaluation app area. Big logo for Saskatchewan pulse growers who are funding us so we can actually pay a programmer to do this, because it's a lot of work. The first version we had of this, when you would click it in some places, you'd have to wait, like in some cases, like a minute for it to run. We've done a lot of tricks to refine the code to make it run faster, etc. So if we look over here, we see on the right-hand side kind of a little bit of how to run it. Maybe we'll look over here on the left. You know, we will say that this application contains information from Agriculture and Agri-Food Canada annual crop inventory. So that's, I want to, give them credit for that. And I also want to say that that this isn't data that we created for this. We didn't create any data at all ourselves for this. We are just using publicly available data that is out there. So so that what's grown on a field is out there. And I say that the crop type is determined with remote sensing. And in Saskatchewan, they're accurate. In talking to Leander Campbell, their accuracy is greater than 90%. And I've checked it, and it seems to be pretty good. It seems to have trouble telling the difference between wheat and barley and oat, and that's not surprising. But in the other crops, the accuracy seems to be much better because there's a lot more difference between lentils and wheat than there is between wheat and oat, let's say, or wheat and barley, which is even closer. We've also used data from Copernicus for the weather, and we developed in the agronomic crop imaging lab, our lab. And so this is how you use it here. So the first thing you do is you get to the, and there's maybe you can show, we have a roads level on that. You can also turn these layers off. But maybe the interesting thing is you can also, if you leave them on, you can also change the transparency of them there. Those of you, we haven't given you the link for this, and the reason for that is we don't want, if we had everybody on this webinar using this app at the same time, I dare say we'd probably crash it. I don't know how much space Google is giving us for free. This is all done, all the web hosting is just done by Google for free on this, because we're not making money on it and we're an academic institution. And so you can see here, you can look around and see, you can move around by dragging and dropping, you can zoom in and you can start to look. And the first thing like everybody likes to do is like, oh, let's go find my field, and maybe the research farm ones end up looking a bit funny because there's so many different crops grown in a small area. Maybe I was working down, we'll pretend I'm from Rosetown today, and we'll go down to by Rosetown here. And so the first thing it says is draw a region of interest with the polygon or rectangle. Well, it's just a rectangle here. We're just going to draw a region. Let's say we farm in this area around Rosetown. We're just going to draw a little polygon there. What we see coming up now is basically our first screen is showing you just how often lentils or peas have been grown in the different fields in that area over time, based on how dark the green, going from light green to yellow to dark green to yellow to red, means that you have a higher frequency of pulses in rotation. Then if you want to inspect an individual field, this is where it gets cool. You can take this point here and click on a field, And you have to answer a question first, because we don't know, we don't have the map for 2022 yet. We ask what crop was grown in 2022. We're just going to say another crop, because nobody's going to be wanting to plant pea or lentil on a field that has had pea or lentil last year, I hope. So we'll just say another crop, and then we'll click that. And then, okay, and so we get, so right away we see this pops up really quick. And we get a high estimated risk of Aphanomyces root rot for 2023. Do not seed peas or lentils into this field. And the reason for that is that we had lentil or pea grown in 2018. So, but if we could look back in our rotation, we've had a fair number of, we've had a fair frequency, more than a 1 in 4 year frequency of lentils or peas grown in rotation in this area. So that's what probably triggered it. We also consider the soil texture. This is probably a high clay soil as well. One other thing we also look at is we look at the precipitation. We look at the precipitation that the last time peas or lentils were grown. So you can look down here and you can look, okay, so in 2018, it was probably lentils in there. We are going to change this so that we'll just show exactly what crop it was. Right now we're just saying lentil or pea. But we can see that the precipitation was quite dry in May of June in that year. So that there may not have been a lot of Aphanomyces. We can't say for sure, but the risk would have been lower. However, in 2016, it was slightly above moisture. There was a good gap there. And then they had kind of normal precipitation, below normal precipitation. So although this is a high, I would say this is kind of on the low end of high risk for these. Let's look at another field to see how this can change. And I'm doing this all on the fly, so I'm not sure what field I'm going to get. We're going to select our answer, another crop. And this one we're getting high as well. Again, this is because the lentils or peas have been grown somewhat recently there again. And you can see kind of a similar rotation. Let's try to find another one that has less, we'll pick a lighter green one here. Another crop. Oh, we keep getting high because there was high. I think it's because it's high clay here and the thing. We might zoom out to another, well, let's try this field here. I guess this gets to the point that there is a high risk. I think some of our parameters are tuned a little bit excessively high in the model here. I'm going to actually start it again. I'm hoping we are not getting a bug, but we'll look in a different area. We'll look in a different area. Let's pick an area northwest of town here. And we can, sometimes it's useful in areas that have never had peas. They'll actually, peas or lentils, they actually appear as white. So it can be a little bit confusing. So sometimes good to pull that back so you can still see where your field is. And let's say this field, these fields here, let's say this field here, we'll check this field here. And we probably know what the answer is going to be for this one. There's a low estimated risk because you know what? It's since 2009. Well, it doesn't appear that they're grown there. Again, this is only accurate to about 90%. It could have misclassified it sometime. You were working on those Ag Canada type on those Ag Canada data on that. So there could be some misclassification, but you can go and check. Let's say, okay, I know that this is my field. I can't quite remember the rotation on this one, or perhaps it's some rental land that's just been picked up. There's been a lot of exchanging of land in the rental market changing these days lately. So you can go and look at that the last time you had a pulse grown in there was in 2018. It was a dry summer, 64% of rain. So probably the risk is lower, although we know in some cases we're recommending an eight year rotation in some cases, that this is a moderate risk. Should know other factors, and it says Aphanomyces crop was grown 2 times since there. We had another instance of it there. So it's more of a moderate risk. Is this telling the absolute truth? No, it isn't telling the absolute truth. we're able just to determine the risk of what's happening there. Let's go back. I want to go back again to that Kindersley Rosetown area because I'm going to have some other examples explaining this a bit more. This is kind of the lentil belt in this area. We're going to, well, now let's just maybe take a look at a larger area of Saskatchewan and I wanted to point something out here that I think is pretty interesting. Is you can if we look here, and this is just showing the frequency of pulses in rotation, we see that there is a very distinct belt. And as I showed you, it is it's hard to get, it can be, you can find fields that are less risky, but many fields, if not most in these areas, are going to have some risk of Aphanomyces, just because of the rotations have had pure lentil grown in them so often. You know, even the fields that are light green, like I showed you in this case, will have some risk of it. And that's the risk that producers are taking. And this field, it just has a moderate risk. In this case, 2012, we had lentils grown, and there hasn't been lentils there since. But that was a really wet year. Is there going to be a risk of Aphanomyces there? There could be, because it's been wet. That's probably a clay soil that also comes into a factor there. It doesn't have that, or a clay loam, I should say, in this area south of Rosetown. So that's going to come into it. But I'm sure most producers would be willing to take people may be willing to take a risk on that, knowing that you could have some damage from there. Let's look at, there are fields, of course, that are much riskier. If we look at a field like this, another crop, and that, of course, is high. And this has been in, there's been some lentil monoculture here, or what appears to be. Again, there could have been misclassification, but it's been wheat, barley, 2022, the model. Oh yeah, we were saying that it was wheat, but obviously putting lentils or peas on a field like this is going to be a high risk. I also want to point something out here. The fields that have, because Agriculture and Agri-Food Canada does this classification on a pixel basis, you could actually get slightly different answers on where you click it. What you should try to do is click the blob that appears in. If there's just a tiny little one, don't click that one, but usually try to pick the darker one that occupies most of the space. What happens in some cases, and I'll show you an example in a second, is that in the really bad years that are really wet, is the root rot can get so bad that the vegetation dies in much of the field, and then the Ag Canada model misclassifies it. So that's kind of the general thing. And also I wanted to show you, but what I also want to show you as well is that this may be not so applicable for lentils, but for peas, there is a lot of areas in Saskatchewan where peas will grow just fine, where peas are very adapted to, where they've hardly been grown at all. We have a lot of land that, especially for peas, that we can still find land that hasn't had any peas since 2009. There's lots of land out there. So I think for peas, part of the issue may be to promote growth of them in areas that haven't had them. And I know lentils we can't move the lentils that much because they tend to grow well in our pulse belt, this area in here. So that's what we'll say. Maybe I'll go back now and show you a little bit more what goes into this model, what goes into it. The first thing is the soil texture. I mentioned that before. There's a data set on Google Earth Engine that's available, that the USDA system, they've used soil maps around the world. So we're just going on that. And this is a soil texture map for Western Canada. What it's showing here, you can see these areas. One of the risks is the heavier textured soils, like these ones down here. These purple ones, these are going to be class 4. And if we go back to our map here, class 4 is a clay loam. So any of these areas that are kind of darker purpley, or even this kind of brown, or this kind of color like the Red River Valley here, this kind of, I don't know, baby poop brown, if I can say that. I didn't use the other word. That indicates a heavier texture and more poorly drained. The temperature we get from the Europeans publish a data set where they reanalyze the weather around the world and utilize and kind of prorate it to local temperatures around there, but it generates a map of precipitation around the world. And so we developed a little program to display that. And here you can see this is just the June and July precipitation. And again, I kind of picked that. Well, it's not really. It's southeast of Rosetown, and you can see here showing that pattern of precipitation. And what was pointed out on those things is, for whatever reason, our even years for that kind of really wet stretch that happened after 2010 were that they were often the even years, and the odd years were the drier years. So if you grew lentils or peas, especially during those even years of 10, 12, or 14 and 16, and and 19 was a bit wetter, that is probably going to make the disease worse. That's the other one. The last one I want to talk to you about, well, I talked to you about the crop rotation already. I already showed you that. But also I want to show you about another factor in this that we want to look at was this whole idea of the patchy to whole field affected and late season lodging versus no symptoms. That we are seeing, that we know that you often see Aphanomyces worse in the lower areas. We haven't put this into the app yet. We want to get data in here. What I'm going to show you here, where is my Earth Engine? This is this field in red here. This is the Kernan Research Farm in 2014. This is an area that had peas on it. It was really wet that year. This is from high resolution satellite imagery that isn't done for the whole prairies. Because we're close to Saskatoon, it's done more regularly, but it's not free like a lot of the other satellite imagery I've been talking about. But you can see the areas that got so wet that the peas drowned out. Well, the good thing is that there's free available. Here's the Landsat image. This is kind of a coarser resolution satellite than the ones we have now, showing that same area. And you can see these areas in red are the areas with lower biomass. And so those are indicating that we have lower biomass there. If we look, interestingly enough, if we look at the crop inventory for that year, it actually got a lot of that field wrong. This brown area is identifying it as peas. The Aphanomyces, or the root rot, or the drowning out, we never clarified what it was that year, was so bad that it's actually identifying this as purple. It thinks that that is actually part of the city there, that's urban development, that their model predicted it was urban development. There was so little crop there, that's what it predicted. But it's predicting peas in these spots. So you can see this patchiness is indicating something. We now have a new satellite constellation up there. Actually the Europeans put it up there, but they're giving away the data. And the nice thing about the Sentinel-2 data set is it has much higher spatial resolution than the old Landsat. We kind of went from something that looks a bit like an old Atari, game set to something that looks like a new Xbox in terms of resolution. And you can see here, this is a field. Well, let's just look at an optimized in color. This is Sentinel here. This is a field I just picked at random. I don't know what it is. I haven't checked it out. This is in 2020 for an area, and you can see it's somewhat patchy. What I want to show you about this is that that's affecting the NDVI. It's lower in the areas that are there. But we also have satellites have bands that can give us information about how wet it is in areas. And what we see is these areas where there's less vegetation are also wetter. That's kind of the opposite of what we normally expect. Normally in the drier areas of Western Canada, we expect if it's wetter that there'll be more vegetation. In this case, we're seeing less vegetation, whereas moisture. That to me is probably an indication that we're getting some, that we're obviously getting some drowning out issues, or we could be getting some root rot issues in areas like that. There's also another water index we can look at here. And in this case, the whiter it is means that it is wetter, and the greener means that it has less wet. But the water index here, the moisture index, which combines one of the shortwave infrared bands, shows us more. So that's kind of wrapping up most of my talk here. I said I've gone for 40 minutes already. It seems like I just started, but I will open it up now for questions. And at the end of this webinar, we're going to send out an email and give you the link so that you can actually use this and fool around with it. And we're not at our final product yet, but we want to get it out there because this is a time of year that maybe you've taken on some rented land. Maybe you can't quite, maybe your records aren't as good as they could be, or maybe it's just a heck of a lot easier just to go and click on something and to pull out the old Hilroy scribbler, or to find the Excel thing, or to ask your agronomist, that you can actually figure it out, because you can start to plan where can I grow my pulses and have the least risk possible. And so that's something that you could do later today on a nice snowy day on April 20th. Okay. Everybody still there?
We're still here. Thank you.
Should I stop sharing my screen maybe?
Yeah, whichever you prefer.
Okay.
Great. Yeah, you're there. So thank you for that presentation and walking us through that and all the data sets and all the complex information that you've so nicely distilled. There are a couple questions. So just I guess as a basic starter question, is this live for growers and agronomists to use this year?
Yep. Yeah,
Okay.
we're releasing it, and it may not be perfect. Some of our parameters, we're still tuning them, but I think if people use it with the understanding that it is a risk prediction, and there are errors associated with everything, even the thing, one of the things I would encourage people to do is to look at their own fields that they know rotations for and see if it's correct, and that may give you some thing, but it is live. Yeah, it will be live after this. Yep.
So just trying to filter through them. Is there capacity to incorporate soil test results, or is that something that could be built in the future?
Yeah, I suppose it could, but I look at the soil test results. If you have an actual number and know what it is, like, and it's, I do to be honest, I don't know enough about, I'd have to confer with my plant pathologist colleagues on how to do that, because my understanding is the test is somewhat quantitative for Aphanomyces root rot, but it's not like you get a number like 63 and that's better than that's worse than 42, that there's error associated with them and the risk. And I think it's something that you could use if you're seeing relatively low numbers from a test and you're seeing low risk here, that makes sense. But if you have a test, if you have a test that shows lowish numbers and you're still showing high risk because you grew lentils 3 years ago and it was really, or you grew peas 3 years ago and it was really wet, you may want to think twice about that. Maybe you didn't go to a part of the field that had enough Aphanomyces, or something like that. So I think the two could be used in tandem. But I think, like anything, we're not proposing some magic solution here, that we need good growers and good agronomists to interpret this information source to make good agronomic decisions. And that's what we're trying to promote.
Maybe shifting over, you mentioned some agronomic decisions, so a few agronomy questions coming in. Do chickpeas carry over the Aphanomyces pathogen, or do they contribute to building up the disease levels in the soil, or do they provide a rotation break?
I'm going to go back to I believe they do provide a rotation break, but I could be wrong on that. And I would hope that we can follow up on that. I was going to try to surreptitiously go over to maybe we should have had a plant pathologist on here as well to answer some of those questions. I don't know if we do. Is Dr. Sabina Benitza on this call, or anybody like that? Or Shama Chatterton? If you are, please identify yourself. I feel like we're on an airplane and somebody's had a heart attack. I'm not a plant pathologist. I've used the information here, so I think we'll get back to you on that because I don't want to give an answer that might be wrong.
Yeah. Okay. Well, we do have a comment, that they're not a host crop. So.
Okay, that's what I thought. I didn't want to.
A couple of questions about some more capabilities of the tool. Could the app or the software be adapted for use in other crops for other diseases? There's a couple examples: Fusarium head bite in wheat or sudden death syndrome in soybean. Is that something that could be accomplished?
Possibly, anything that, again, it's risk that we're seeing here. There's nothing, the odds, there's sometimes imagery and satellite and remote sensing is oversold, and people will talk about spectral signatures that can identify specific plant diseases. Well, that's not true. There's nothing from space that can tell you if a plant's dying from, if it's dying from root rot, or it's just dying from drowning out, or it's just dying because somebody sprayed something on it that they shouldn't have. It all just looks the same. Plants get yellow and then they turn brown and die. Sometimes they'll become a little bit red in there as well, but to sort out very fine differences, we can't find that out. So for diseases that are influenced by rotation, certainly we can provide that information. And we will be releasing in the future some other apps that can do other things as well. One other potential use, just talking to somebody recently, actually at Eric Johnson's retirement, this was you guys' publicity, came out the same day we had a party for Eric Johnson retiring, and people are going, hey, I saw you on Twitter. That's when I started to get worried about this. I thought, oh my God, it's going to be so many people showing up to this, which I think we have. Thank you for coming out. And one person mentioned to me, I think this could be a great tool for herbicide rotation. You don't know exactly what herbicide, but if you're seeing a lot of pulses growing there, you know that field probably has had group 2 on it. So if you're seeing some potential carryover, they were thinking of looking at if there's fields that are showing some potential IMI or group 2 damage in subsequent non-tolerant crops, that they could go on this app and look and see how often pulses have been grown in rotation to do that. And similarly for planting as well, if you see a lot of pulses in rotation, and really close, and if it's land you've just picked up and you don't have rotation information, you could avoid a susceptible crop, or perhaps grow a wheat with the IMI tolerant gene in it, so that you can avoid any potential herbicide damage issues.
Great. A couple questions along the theme of whether or not the app or the tool is adapted or user friendly on mobile devices and cell phones.
It'll work on them. We haven't optimized it yet for that. And that's something that I think actually I'd like to talk with you guys at SPG to see if that's something we should prioritize or not. It will work on it, but you're just kind of limited by the small screen. So an iPad for sure, but if you're, and I've got one of these big monster phones, that's large, so there's probably enough screen space on there, but it may, to be honest, I haven't checked it recently, but I have checked it in earlier versions and it did work, but it is the space issue that is a bit of a thing. So that's a good point, that people will want to do it, and we should. I think the answer you'll probably will say is yes, and I can't promise if we'll do that or not, because sometimes, I learned a long time ago talking to my computer science friends that the question you ask usually can be solved in in an hour, a week, or a year. There's basically 3 categories, and you often don't know which one it's going to fall into when you ask the question until they take a look at it. Yeah.
Okay. Just to follow up, I guess, on the capability question around what, in your opinion, what other data inputs or information do you think could be used or would be useful to you to improve the app?
Well, the one thing that we've just through a research grant application that we just applied to get data, we've gotten access to a pretty good digital elevation map from the German aerospace. They have a couple satellites, the Tandem-X, and so we have well, essentially pretty much the best of publicly or the best available digital elevation model. So one thing is we can start to actually model the elevation of the ground more accurately than we can with traditional ones, and look for wetter areas that should be wetter, and that will help us in we can have that thing. Is that area where the biomass seemed to be lower in a wet year? Is that where we would predict to be a wet area? So that would help as well to know that kind of thing. Although just predicting it, just seeing the reflection of the bands. But the trouble is, of course, in some years, your satellites will be coming over when there's clouds out. And our optical imagery can't sense through clouds. We're currently working on methods that use side aperture radar. I have a graduate student, Hansini Fernando, that's looking at using radar sats like Heather McNairn uses for other applicability as well. And the great thing about radar sats is the radar can go through clouds and bounce right back. So you can essentially image it. The imagery you get is somewhat, it's not as highly detailed as the optical imagery, like especially the stuff I showed you at the end. So it's a little bit more like reading tea leaves a bit, but it does give you information if there's a long stretch of cloudiness that you wouldn't get before. Because right now we have, for most of Saskatchewan, we'll have our optical Sentinel satellites flying over every 4 to 5 days on average. Our land sats will be every week, about every 8 days on average. And so we're getting pretty good with all the satellites out there. We're getting pretty good coverage. But if you have, in some areas, you just get, it just happens to be cloudy every time they're coming over. So in those situations, you don't get it. So we're looking at different ways of getting information in that situation. Yeah.
Okay. Couple questions here, sort of along the same theme about, can you draw your field boundaries in? And would the addition of field boundaries and user-entered crop rotations help make the system more accurate?
Yeah, it could. In field bound, we didn't put a field boundary thing. You can draw a little polygon. You can draw that polygon the size of your field if you want. We're toying with the idea, and we're not sure if this is a 1 week problem or a 1 month problem, of having a legal land location entry system. We'd like to get that you could put that in, and I know we should talk to I think we should talk to the Saskatchewan Soil Information System, the SASC system, because I think they have that there. If we could port some of their code to ours, because that would be a nice feature. I think if you could just put in your legal land location, the southwest of 3010 3 west of the meridian, right, and bing, goes to your field, right? And the field border issue is actually, that's closer to at least a 1 year problem. We've been working on automatic methods of drawing field boundaries for a long time, for at least a year. We're starting to get pretty good at it. The issue we're trying to do every field in Western Canada, so you have to have an automatic procedure, and you're dealing with 150 million acres, so or maybe not that much, but let's say that much. And if you're trying to draw a quarter section, you're trying to draw 1 million boundaries, right? So it becomes a computing big data kind of issue, and that's the space when we're a lot of the work we're doing now. We're working on either in the cloud, like this is on the Google's clouds, or we pull stuff down and run them on essentially supercomputers, big, powerful. This stuff won't run, the stuff that we're doing on large areas won't run on regular computers, Okay.
And interested in your opinion or the ability for growers to upload their crop insurance data that would help in accuracy for crop history information, or if that's something
that's a good one,
able,
and we do have we are doing a bit of work with crop insurance. These aren't we haven't, like, I don't think we can use their data to plug into this one. You know, they haven't given us the right to do it, so obviously we're not going to do that. So that user reported data, that would be an interesting thing just to validate. Well, actually, that crop insurance data is what they train this on. So I suspect that there wouldn't be a lot of difference between it. You know, I think, yeah. So I think we'll talk about having a, you know, if there is a, I suppose, you know, I'm just thinking, I'll talk to my programmer about having another thing, like something that you could click. Is there an error in these crop rotations? And if you click yes, then you get an opportunity to change one of the ones that are incorrect. That may be, I think, probably the best way of doing it. I think that would be the simplest way of doing it, rather than trying to port it to get another data set would be more complicated. But if we could just have a thing like, you know, that I don't think it would have to pop up every time. It could just be something that you would click over here. You know, if these are, is there a mistake in the crop rotation? If you click yes, then you can go and change it. Yeah. So that's something we could probably do. I'm pretty sure that that's like a one-dayer.
Good. Well, the questions have slowed in coming into the chat, so I think we'll maybe take the opportunity then to wrap up. And thank you again, Dr. Shirtliffe. It was very interesting and I'm sure very useful.
Okay.
Any questions?
Well,
yeah, go ahead.
I'm very humbled that so many people came out, that so many people signed up for this. I don't know if they all came out. Thank you for those of you that have stuck around this long. I know, you know, maybe you're off doing something else, but I really appreciate it. You know, I'm very happy to be at a part of my career where we can just kind of focus on, you know, scientific publication is important, but if you can get something that's right to the growers, and people use it, that's very, very, very gratifying. So thank you, growers, for showing up, and thank you, Saskatchewan Pulse growers, for funding this research.
Awesome. So yeah, and just to wrap up our portion of the webinar, like I mentioned, we will have any unanswered questions. We can attempt to get those addressed after the webinar. We are going to email answers to the attendees if that's the case. Again, the recording is going to be posted on our website, and you'll receive an email on how to access that. You'll also receive an email with a link for a survey, and that's to share your feedback with us, and that helps us deliver valuable extension opportunities like these ones and continuously improve. So that wraps up the webinar. We want to thank everyone and wish everyone a great day. Thank
Thanks.
you.
Bye.
Bye.